Hello, calculus student. This video is for chapter 4.5, part 2. We will continue using derivatives to look at how we can determine whether a graph has is increasing or in an interval that is increasing, decreasing, or concave up, concave down, and also discover the local maximum, local minimum, and inflection point. So last time we talked about how we can use first derivative to find the interval of increasing, decreasing, and local max and min. Basically, if you look at the two graphs that we have here, when a graph is increasing, the tangent line slope in all these intervals must be positive. And when the graph is decreasing, the tangent line slope, which is f prime of x, is decreasing. So if you do a test on when f prime is 0, and then you look at the intervals, you will see that it is increasing or decreasing. And also whether you have a maximum or minimum, because if you go from a negative to a positive, then you must have gone through 0, which is the lowest point. If you go from positive to negative or from increasing to decreasing, then you must have gone through a local max. Okay, so that's the idea of the first derivative test. So basically the first derivative test would be you would find f prime of x, solve it to 0, so find all the critical point, use the critical point to do a number line, and then do testing, and then draw those plus, 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 minus, minus, minus. If it's a plus, it's up. If it's minus, it's down. Between up and down, you would have a local max and min. So do another example. So our function now is x squared e to the 5x. So let's do first derivative test. So f prime of x first. And you recognize that this is a product, right? So we have to do a product rule, f and g. So we'd say f is equal to x squared, g, or I should not use say f because it's f, but you know, we have to do it this way. F prime is 2x, g prime is what? Chain rule, 5e to the 5x, right? It's basically e to the 5x times 5. So f prime would be fig first, 2x e to the 5x plus x squared 5 e to the 5x. And so there's a lot of things that you can factor out. X and e to the 5x can be factored out. And it would be 2 plus 5x, right? And if I set it to 0 to solve critical point, what would happen? So e to the 5x can never be 0 because e of something can never be 0, but x could be 0. Also, 2 plus 5x could be 0. That means your x can be negative 2 over 5. So we have two numbers, two critical numbers. So we're going to put some space here. So put our number line down and draw the number line. So the negative number, negative 2 over 5 on this side, 0 is here. So you just cut out your intervals in here. And then we are going to do test point, right? So what number is, and what do we use to test? It's x e to the 5x, 2 plus 5x. Use this to test. This is f prime of x. So we test x equal to negative, so negative 2, negative 1 maybe. So we will say negative 1 e to the negative 5, right? We could actually use decimal to do. And then 2 plus 2 minus 5. So I have negative, negative is positive. And then what is the next one that we can do? Negative 2/5. Oh, that's really hard. So, but it's negative 1/5, let's say, right? So we would say negative 1/5 is still negative. E to the negative 1, right? Negative 1. Negative 1 times 5 is negative 5, but negative 5 times negative 1/5 is still negative 1, but this one is always positive, so it doesn't matter. And then you have 2 plus 2 minus 1. Oh, this is positive, this is negative. I have a negative number. I guess you can use decimal to do. So next time I'm going to do that. And then let's do x equal to 1, which is positive. So become 1 e to the 5 and then 7. This is always positive. So we'll just draw our arrow. So this is f prime. This is f prime sign. F would be what? Going up, going down, going up. So in this interval, that is local mean. And this one, not interval, this point is local max. Right? So let's write the answer. Increasing. Increasing is this one. From negative infinity to negative 2 over 5. Union from 0 to infinity. Decreasing. Decreasing is from negative 2 over 5 to 0. L local max is our negative 2 over 5. Let's put it back into our decimal because I don't want to calculate it. It was the original function, okay? X squared e to the 5x. Right? We'll say negative 2 over 5. 0.02. I think it's not an exact number. 0.02. And then local minimum is 0. So if I do f of 0, what would it be? 0. Oh, well, actually, you multiply that. Of course, it's 0. But that's the local max. So that's how you do it. One more. Oh, this one we will do it in class. Okay. Because there's not enough space. So basically, again, you do. Then the second test that we can do is the last test. First derivative test allow us to find increasing, decreasing, local max, local mean. Then the second test we're going to introduce is called concavity test. So just like the name, the concavity test means you can use it to determine the intervals of concavity. So that means you can determine if it's concave up or concave down, and also if there is point of inflection. So how do you do it? If you look back on the previous section, how do I know it is concave up? It's concave up because the slope is gradually increasing. It was negative, or even if it's not negative, it was very gentle slope, but gradually become high. So that means f prime of x itself is increasing. F prime of x itself is increasing. So, and then what is it concave down is when the slope is become positive to negative, it's decreasing. So f prime itself is decreasing. So that's how you do for the concavity test is you will actually find f double prime and use it to find the critical point of f prime. So you're thinking, when is f prime positive and when is f prime negative? Analyze f prime on the subinterval, and then if f double prime is positive, that means it's concave up, because positive means it is increasing. And one way to remember it is up means happy. So concave up means you have a happy face or happy smiley. Gosh. A smiley face, so you would have a upward trend. So that's something that easy to remember. Up, right? Concave up, happy. And then concave down. Down means sad face, negative sad face, negative like that. Okay, so that's how we do the concavity test. So basically like the first derivative test, except you are looking at the second derivative. Okay, let's do it. First example, this is the function, so we'll do first derivative first. Equal to 3x squared minus 8x plus 1. But we're doing concavity, so we have to do one more. Second derivative equal to 6x minus 8. Now we do 0 equal to 6x minus 6. We want a critical point of f prime. So x would equal to 6x equal to 8, x equal to 4 over 3. And then we do the same thing. We draw the number line, right? 4 over 3. We put in here for testing. What is less than 4 over 3? 0, okay? X is equal to 0. Test. 6 times 0 minus 8. Oh, it's negative. So this is f double prime sign, negative, negative. And then we do a x equal to, what is it, 2. Okay. So 6 times 2 minus 8, of course, is positive, right? Positive, positive. So we say, okay, now we'll draw the picture. So f, when it is negative, it was set face, concave down. Because the slope is actually decreasing. So it was up and then decrease. Happy face, concave up. Okay, so we'll say, do I have change of concavity? Do I change from positive to negative? Yes. So this is an IP, inflection point. Okay, so we write down the answer here. Concave up is from 4 over 3 to infinity. Concave down is from negative infinity to 4 over 3. Inflection point is x is 4 over 3. Y is what? I don't know. I have to put it in. Write down what the formula is x cubed minus 4x squared plus x plus 2. I'm just going to use decimal to do. X cubed minus 4x squared plus x plus 2. We can also use decimal to verify that we did something correctly. What was it? 4 over 3? Oh God. Yeah, 4 over 3. F of 4 over 3, what is the value? 4 over 3. That is negative 1.07. Really? X cubed? Oh, well, because it's 4 over 3. Negative 1.407. Negative 1.407. You can briefly go over it. On the left of 4 over 3, it's the red one, okay? The left of 4 over 3, which is 1 point something. So it's kind of like here, right? 4 over 3. Let's 1 point something. It's here. It's down, right? After this, then it's up. That's the inflection point. Okay. We have another one, so we'll do it in the third video.